So this is a story that I'd like to tell you. It's about a person. His name is Gaius Plinius Caecilius Secundus. It's a mouthful. He was born in Italy 23 years before Christ. After Christ. Okay. So in the year 23, so this is like 2,000 years plus ago. Now this guy has written an encyclopedia. It's called Naturalis Historia in 37 volumes. And that encyclopedia supposedly had everything people knew that time in it. So it's like everything in your library, Wikipedia, the internet, everything is, we managed to put it in 37 volumes. Now, the story is not really here, but about a story within that encyclopedia. So in that encyclopedia, he tells a story about a goldsmith that brought a plate to the emperor Tiberius, and the plate was made of a new metal. So at that time, people know silver, gold, copper, but this is a different metal. And that metal was almost as shiny as silver, yet it was lighter and it was stronger. A totally new metal, as shiny as silver, yet stronger and lighter. And the goldsmith claimed that he managed to extract that metal from clay. He just took clay and extracted that metal from. And he also said that only me, only I, and the gods know how to do it. Now, let me ask you a question. What do you think this metal was? What do you think this metal was? As shiny as silver, yet lighter and stronger. Yes? Aluminium. Wonderful. It was aluminium.
Ooh.
Thank you. So that plate was made of aluminium. Now, I want you to think of being in the position of that emperor. So suddenly, you know, silver is how wealth is measured, and this goldsmith is bringing me a metal that is better than silver, that he extracted from the soil, from clay, using a technique that only himself and the gods knew. What would you do as an emperor? Okay, so let's just pick. So you said something here?
Find out how to get it.
Find out how to get it.
Kidnap him?
Kidnap him. Yeah, pass it around, yes. Yes. So find out from him. Please tell me, how did you make it? Kidnap him, yes.
Threaten him
Threaten him to do what?
to work for him.
Threaten him to work for me, yes. Anyone else want to say anything? There's a hand over there.
Torture him
Torture him to do what?
to get the recipe.
To take the recipe, to take the procedure from him. Anyone else? Yes, there?
Make an exchange for information from him. Maybe he wants money or land so that he will trade his
Right.
information.
So negotiate
Yeah.
and give him something and take
In exchange from his information on how to extract the
right,
aluminium.
how to extract that shiny metal from. Anyone else want to say anything? Yes, one here, Chris.
Be friended with him.
Yes.
Like if you can be friend with him for long enough, then he'll tell you like most of his secrets and
Right.
like recipe or how you do it.
Right. Great. So apparently you guys are focusing on getting the information to learn how to get that new metal so that the information about how to extract it becomes available. Unfortunately, the emperor didn't think like you guys because he killed him. And interestingly, this is a true story. So the emperor thought in a different way. What makes me rich is my control of a limited resource, which is silver and gold. Now, if suddenly this resource becomes available, that's a threat to my power. That's one way of thinking, and luckily you guys are thinking in a different way. Now, let me tell you a bit more about the aluminum specifically, because I believe that the story is very educational. When we realize that we can extract that metal, aluminum, from the earth, the process was extremely difficult, time-consuming, and aluminum was very rare. As a matter of fact, it used to be, just a few hundred years ago, more expensive than gold. Can you believe that? So, story goes like this, that the Emperor of France had few sets of utensils and that are made of aluminum that were to be used by him and by visiting heads of state. Only him and visiting heads of state, and anyone that is of a lower rank will have to accept forks and spoons and knives that are made out of gold. This is a true story. Now, the reason is, aluminum doesn't exist as a free metal. You cannot just dig and get gold or silver like you do. The aluminum is available as an oxide that's called the bauxite. And to extract aluminum from bauxite is not a straightforward kind of process. But apparently 2,000 years ago, someone discovered the way to do it. Unfortunately, he was killed. And that delayed the unlocking of this resource up to just a couple of hundred years ago, where we managed to find a way to extract aluminum in a cheap, safe way, and that made all the MacBook made out of aluminum, the aluminum foil that you have in your kitchen, it becomes something that is available. Now, this is a story that's very important, and there's a reason why I'm telling you that. Because from a technology point of view, from an engineering point of view, we can tell the story of human civilization as a story with milestones when either material was made available or energy was somehow made available or information were made available. So when aluminum was so scarce and someone thought of a way to make that resource which is available, but we don't know how to extract it, unlocked, then suddenly we have access to aluminum. Or likewise, when we had access to iron, to copper, all these things, all these resources as materials, including the Stone Age, as a revolution, happened when humans realized that you could shape stones into tools. Then you can hunt better, you can have a better lifestyle. Likewise, when it comes to energy, we had fire, but we didn't control it. The moment we controlled fire, we have unlocked a huge resource. Then when we discovered that we can get coal, then that helped us actually have leaps in terms of improving our economical standing and also quality of life. The same thing happened when we discovered petroleum and we managed to get petroleum in good quantities from the earth. Now, the interesting thing is this, and this is really the premise of this module or this course, both the civilization part and the emotional intelligence part. The premise is this: everything we need is available in the universe. So if you think about it, what do we need to live? We need food, we need water, we need air, we need materials to build our computers, to build, to get our clothes, to build our cars. Everything you need is there. And it is waiting for you, for us to unlock it. Look at the lake. You have water there. Can you drink it? You can't. But if you find a way that you could easily convert this into drinkable water, you've unlocked the resource. Currently, it's a resource, but we didn't unlock it. You go out there, it's hot. So this sun that's hitting us with an energy that maybe in 1 hour, if we could harness it, it's enough for us to run the planet for a year. But we are still unable to harness it in an economical manner, and hence we are still dependent on fossil fuel. So just like when technology unlocked the aluminum, you guys all are in a position, as you progress in your studies, to unlock other resources like material, energy, and information. And I want you to keep capturing this thought into you. Remember when we say everything starts here in terms of CDIO, you need to have the thought that you are on a journey to unlock resources. And these resources could be either material, could be energy, or information. As a matter of fact, there is a body of thought that says what we really need to unlock is only information. Because if we have the knowledge, we will know how to get the energy from the sun. If we have the knowledge, we will know how to get the materials that we are looking for. And hence, education, which is about making sense of the information that we have, converting it into a useful knowledge, is such a powerful thing that we could all embark on. So every leap, when we have a major unlocking of a resource, is called a revolution. And there is a reason why it's called a revolution. A revolution is when there is a specific point in time where that some change happen, where what is before it and what is after it are different. So if discovering how to get aluminum cheaply from mud is a revolution, then before it, aluminum was a sign of richness. Before it, it's something that everyone can get. It's totally different. If making a steam engine is a revolution. It means before we have that point in time where suddenly we have harnessed the power of steam, we all do manual work. Now, very little manual work is done. And we depend on machines in an extensive manner. Now, there are revolution that has happened in the future of humankind. And I think we all watch the history of the world in 2 hours. But I want you to think that we still have so many challenges ahead of us that will require future revolutions, technological revolutions, in order for us to be able to unlock resources. So what I'm going to do throughout this course, I'm going to work with you to study these revolutions one by one. And we see how this revolution happened and what was the resource that was unlocked. And I hope that as we move on, you will see history in a totally different eyes. You will see it from an engineering point of view. Any question? Anyone tweeted anything? Mike? Of relation to whatever we've said? Nothing. Okay. So the revolutions, I'm going to read it for you because I wanted everything to be on one slide. 2.6 million years ago was the Stone Age revolution. That's really the time when we started making tools out of stone. And this has unlocked the material kind of dimension. So you don't have to, it's a bit too small, so you just need to listen to me, relax. When fire became under control, 800,000 years BC, we have unlocked a major source of energy, including when we can cook food and we have access to more calories. Then when the agricultural revolution, 8,000 BC, took place, we have unlocked both energy and material resources. Because now a small piece of land can actually support more people than the hunter-gatherers can be supported. Then when the wheel was invented, 3,500 years before Christ, more than 5,000 years ago, in Mesopotamia, we now can convert the animal force, the human force in a very effective manner. So it's a matter of energy kind of transfer that allow us to build more efficient machines and transportation tools. Now the printing press, which was invented in 145 AD, 1450 AD, provided access to information. That was really the time when books become cheaper. Instead of books used to take, like a Bible used to take months or maybe years to complete, where it was commissioned by very rich people, and people don't have access to that. But the moment we can print books, then access to information become widespread. And the scientific revolution, which happened in between 1550 and to 1700, that's the time where, because of the availability of the books, we started to question the norms that being accepted widely by the society. For example, that Earth is flat, sun revolves around Earth, and things like that, because that was the common knowledge back then. Then when you have the Industrial Revolution, 1712, where the steam engine was introduced, that was a time where, again, access to energy, sudden access to huge amount of energy was made available and made cheaper. Now, the digital revolution is a bit difficult to pinpoint when it started, but it relates to the time when we started to have computers, and that really gave the rise to everything that we have today. I don't think you guys can imagine life without the internet, let alone for 1 hour, let alone without computers. So this is something that made everything eventually different. The first programmable computer was invented in 1936. Then we have the information and communication revolution, which is through the website and the World Wide Web. And after this, we have the knowledge revolution. You see, when you have a huge amount of information online, the challenge is not access to information. The challenge is what do we do with that information? So you have now, we are working on how do we make sense out of these huge heaps of information out there. And the final revolution that I believe is brewing as we speak is the green revolution, which is about or related to all the activities that the humans are doing and how they are impacting our environment and the availability of resources, and we are getting more and more aware of our impact on the environment, and we need to maybe change the way we think, the way we live, the way we educate our people so that we can have a sustainable way of life. So these are the revolutions, and later we are going to, maybe next week, we are going to work with you on them, a revolution by revolution, and we are going to really drill down to how this revolution took place and what are the circumstances that led to the unlocking of that specific resource, whether it's material, energy, or information. So this is to really provide us with a framework of thinking as we move on in the semester. Do you have any question? If you have no question, I will invite Christopher to present to you the projects, and you will put them into groups as well? Yeah.
All right, so good morning, everyone, or it's like afternoon already. So there's going to be a project for this module. So, and the project consists of 20%. All right, so myself, Mike, and Mushtak would be working very closely with you in trying to make the best of the project work, okay? Part of the project work is to introduce you to CDIO, as well as what it feels like to be working on a hands-on kind of engineering system where you build something from scratch and, in a way, get it to run, okay? So we thought about it, and we came up with the concept of having a competition, okay? So basically, it's going to be a competition where you will be divided into teams, and you will build a robot, and you would race it, okay? So as it is a competition, so marks will be given for the winners, all the way down to the not so successful ones, okay? So what is RoboRace? Okay, basically, it is a robotic challenge where you will build a robot that can complete a racetrack in the shortest amount of time, okay? You would have 15 weeks to do this, okay? So the weeks start counting from the next one, okay? So throughout the 15 weeks, we will provide you with any support, any help that you need, any advice to help you complete your robots and race it at the end of the 15 weeks, okay? So what we are looking for is that one team that builds the most outstanding robot that completes it not only in the fastest time, but has the most creative design, has the most wise use of materials, is the cheapest, and so on and so forth. Okay? So what we're going to introduce you to is two very important components. The first is using something we call Arduino, which is like I would say like a processor of sorts, like a microprocessor kind of thing. It's a board where you can use to program the robot, okay? So it is compulsory for all of you to use this, as well as you have to use your iPads to control the robots, okay? That would be the challenge. But I'm sure that you guys are here to become engineers, so this shouldn't be, yes. All right, so what you're going to do is,
the question first
okay.
because we didn't capture
His question was, how do we control the robot from the iPad? Is it based on writing your own program, or using an existing program, or using an app? So to do this, basically what we found is there is an app that controls the Arduino system. Okay, so that's the easiest method. But if in any case you are willing to write your own programs, you are willing to write your own codes, and you can do it, then that you'll get more marks for that, right?
I think Mike want to say something also.
Okay, basically, right, the communication between the robot and the iPad would be done using Bluetooth. So, and the interface to communicate with it, there is an existing app that lets you do something quite similar to that kind of control. But yeah, it's kind of up to you really, like Chris says, what exactly you want to do. Oh, sorry, there is an existing app that actually lets you do this kind of things, okay, on the iPad. But in the end, it is up to you whether you want to do it that way, using an app, or you want to write your own app, or if you can think of some other more interesting ways to run this communication, it's up to you.
Let me say a few words here. You guys are going to receive your iPad today. Okay? The iPad is a very powerful tool. The iPad has sensing devices. So it can sense speed, acceleration, inclination. Guys, please stay with me. This is very important, please. If you have a question, I would really appreciate if you leave the tweets now, raise your hand. I'm serious because this is actually a very important thing. So the app is, first, it's a computer. So it can process information. That's number one. The iPad is, first, is a computer. Second, it has a number of sensing capabilities. So it can sense light. How can it sense light? Light sensor. So what do we call this light sensor? We call it a camera. Yes. But you see, you need to start thinking like engineers. And this is the difference between an engineer who thinks of technology and deploys it accordingly, and only the end user who would just need a simple interface. So this device that we call iPad, it can process digital information. It can also sense sound. It can sense light. And it can sense acceleration and inclination and stuff like that. So what we are going to do is, we are going to get you to build a robot. So the robot will entirely up to you how you are going to move it. If you want it to have legs, if you want it to, you have a question? Yes, can you give him the mic first? Thanks a lot for asking the question. And shout.
Will the materials be provided, or do we get it ourselves?
Okay. So the question is, will we provide you the materials, or will we ask you to get them yourself? The major pieces of materials will be provided. So the iPad is provided. The processor is provided. Yes, I'm serious. And also, I hope after this, Mike and Chris will take you on. Have you been to the engineering labs? No. Okay, you guys are engineering students. So they will take you to see the engineering labs where we have a lot of machine and a lot of things that you guys are going to be able to use. So the key basic materials will be provided, and we don't want you to actually go and burden your parents to buy any extra material. So we will have plenty of woods and metals and other things that you could use. So I could say, with a bit of innovation, everything that you need will be provided. Now, there is a reason why we did not provide the robot base, this, and the iPad, and we give everyone the same materials. Do you know why? because everyone is going to give us the same thing. So that's why what we say, the brain, which is the iPad, will be the same. Now, if Mike or Chris or I say, use that app to control that board to move this robot, I can tell you all of you will come up with the same thing. So we are specifically defining the challenge loosely so that those of you who would like to take this to a new level will be able to do so. And we will be pleased to be surprised. So what's going on? What's your name? Wei Xiang. Wei Xiang. Right. You are on Twitter all the time? But this is amazing, isn't it? Yeah. It just so happened his eyes is always there. Yeah. So what we will do is you will be given classes on how to do the basic programming. A key thing here is this, which is really a transformative kind of mindset. You guys are engineering students. And we are talking about engineering as a process also to unlock the potential of materials, information, and so on and so forth. So you don't wait for me to teach you which app to use. You go and do a search. Now, the Arduino board is a multi-usage, kind of do-it-yourself controller. Now, you take note of this, DIYdrones.com. Do-it-yourself, DIYdrones.com. This is an entire company that makes drones using the Arduino board. Now, this Arduino board is going to be a major part of your study. DIY drones, one word, DIYdrones. Do you know what's a drone? Yeah, this is a remotely operated kind of flying platform. So you could, what we want you to do is to surprise us with coming up with great solutions so your robot looks wonderful, looks great, operates in a different way, and also controlled differently. What we will assure you is this. We will give you the basic support and information so that every one of you, putting enough effort, you will have an operational robot. That's the promise. Now, the sky is not even the limit. You can go beyond that. And that's entirely up to you. Whether you want to design your own app is entirely up to you. And we will highly appreciate it. So this is the time where you can take, and we would like you to take ownership of your learning. Now, I just want to mention one thing, because in some of your minds now, maybe this is a question that you say, I'm doing chemical engineering. Why would I do these boards and controllers and so on? Or the other guy say, I'm doing mechanical. I never thought of EE. But why am I asked to do this? You see, engineering is moving in a certain way where everything that we do is multidisciplinary. It's very difficult now to pinpoint a place where the electrical engineers don't do mechanical stuff, or the chemical engineers don't do electrical and computer-related stuff. So we want to get you prepared, regardless of whether you guys are doing mechanical, chemical, or electrical. We want you to be ready so that you can control systems even remotely. Now, beyond the rules and regulations that Chris is going to share with you, if you want to create a situation in which you control your robot through the internet from a different part of the world, be it, make it, surprise us. that's really the basic message of this project. Now, just to assure you, I'm a mechanical engineer. This guy is a chemical engineer, and Mike is a chemical engineer as well. None of us even is electrical engineer. But we know that the Arduino board is built so that even non-engineers can use it. Is it challenging? Yes. Yes, and it's meant to be like that. Will you be supported? Yes. And not only by us, we have all of you here. And you know what other support and resource you have? Even the online students who are from all over the world are people who could be a source of support to you. And the internet and. So that's when it comes to the technology. Okay, so I pass back to Chris.
All right, so anybody has any other questions before I move on?
Yeah, can you like specify the term robots, like a robot that walk on two legs or a robo car, any type of design of robots?
All right, so if you guys didn't get his question was, is there any specification to the robots? Is it like, does it have to be a car or does it have to have legs? So there are no specifications because you want to leave it up to your own creativity to find out what's the best solution to the challenge. Okay?
What's the medium that the robot will be traveling on? Is it water, road, or air?
Chris, maybe if it would be to share the challenge first. Let's share the challenge. So he has a challenge. So he wants a device that can do this. Whether do it with wheels or legs or wings is entirely up to you. So it's an.
All right, I actually have like about 5 more slides to go through. So all your questions, I'm gonna present it later. Okay, so we'll just go one by one. Okay, so you will work in teams of 4 or 5, to build the robot in 15 weeks and then race it at the end. Okay, so we will have a test run on week 16. Okay, so that you can actually run your robots on the actual track and make any improvements or alterations after. And then 2 weeks later, we would have the actual final race, okay? So to your question of, is it on water, air, or road? The easiest option right now for you is the road, okay? For you to build a flying robot or a water robot, that is quite difficult for this stage. Okay, so we'll start off with the easier one first. But if you want to build a flying robot, by all means, you can go and do that. All right? Okay? So you will be tested on a few components. First is how well you maneuver the robot. Okay? The robot has to be able to turn. It has to go up slopes. It has to go down slopes. And it also has to go through what we call a tightrope, which is basically a very narrow stretch on the track. Okay? So it must be able to do all this without falling off. That means that the robot needs to know how to balance itself. Okay? You're also tested on the speed of your robot, as well as the design and the use of materials. All right? So each team would have 2 times that they can run the robot on the track, and we would take a time for each of your attempt, and we will record it as the average time. Okay? So the actual layout of the track, as well as the specifications and the design, we are going to share that to you soon. Okay? So, like everything else, there's going to be marks for every single one of these components, and this is upon 100%. Okay? So, when you start this week and the following weeks, the first thing that you need to come up with is a design proposal of your robot. Okay? And that constitutes 10% of the entire marks. After that, there's also meeting logs. So as engineers, we are all keeping a logbook when we work on projects or when we work in the industry. So this logbook is basically a journal of what we found online, the information that we have, as well as all the meetings that we have with our group mates. So it is our culture, and we want to share this with you. So you need to have meeting logbooks in a group, and that constitutes 10% as well. All right? After that, you would have an oral presentation. So this is to test you on your teamwork, as well as the design of the robot and the use of materials. So that's 20%, and that's going to be towards the end of the race, as well as you are required to make a promotional video. So after all the hard work that you've put into making a robot, we want you to share this with the world. Okay, so you have to make a 3 to 5 minute YouTube video introducing your robot, okay, and upload it on YouTube. That would be 15%. And the actual race will constitute 45%. Okay, so it's about half of the entire marks. So 20% on how you maneuver the robot and another 25% on how fast you do. So the 25% for speed is allocated according to the ranking that you finish the race. Okay, so naturally the first team that finished would get 25%, and the next team would be somewhat lower and lower and lower until the last team. Okay? Oh, okay. Actually, that's all that I have. All right, so if anybody has any questions now, you can raise your hand so I can address them. All right. The question was about the energy source. Okay, if it's something that I have not specified here, it is really up to you. If you want it to be solar powered, if you want it to be, I don't know, hydrofoil there and that kind of thing, it's entirely up to you. So if it's not specified by any of us, it is really up to your creativity. And that's what we are looking for. We want you to be different and we want you to have fun, right? Okay, any other questions?
Can we like get coding lessons? Can we get coding lessons since you said the programs can be made by ourselves?
All right, his question was, will there be lessons on coding? Okay, whatever that we will share and guide you on is the very minimal basic level. This is still a project and we don't want to be spoon-feeding you in, okay? Because when you move on to engineering, all your projects are done independently, okay? The supervisors are there to just tell you what's right and what's not, and not there to give you the information directly. So it is a lot of independent research and study on your own, as well as together with your teammates. Okay, that's why it's a team project, so that you have each other to support yourself, as well as to help you get through the entire process. Okay? Anybody has any other questions? All right, so what I've done is basically I've randomly assigned each and every one of you into groups. Okay, so I'm going to share with you your grouping now, so please take note of that. And then after this class, Mike and I will bring you for a quick tour of the labs, but we will not go in because not everyone's in proper attire, so we'll just walk on the outside. And after this, please, you can go into your groups and start discussing. And really, everybody needs to read up on what's a robot, what's the capabilities of the iPad, so that when we come for the next class and we provide you with the necessary materials, you can immediately start. All right?
Yeah, so you guys, meanwhile, we want you to start searching YouTube's projects done by other people about how to use the iOS, the iPad or iPhone to control Arduino board. We will write how to spell the Arduino so that you look for it, and there are crazy things available out there. Chris is going to make this available on Open Learning as well. You just take note of it, but he will upload the file on Open Learning.
All right, anything related to my physics class will be done on Facebook, but anything related to this class will be done on Open Learning, okay? So you need to be always checking both platforms, all right? So can the people at the back actually see? Okay?
You can come closer.
Yeah, you can come closer, and I'll just go through like slowly so that you can see all the groups. There will be a total of 16 teams, okay? If anybody, for whatever reason, have no groups, please come and see me after the class, all right?
Can come closer.
Yeah.
Feel free,
come. Just see where your name appears and what number is next to your name, and that's enough, okay? All right, did everybody got their groupings? Did anybody does not have a group? Does anybody want to switch groups? Does anybody want to switch groups? No, you are not allowed to, okay? Whatever is here already. And all the marks that I mentioned just now, it's gonna be a group assessment, okay? So everything is a group effort and you'll be assessed as a group.
So if you have no further questions, you can go to the engineering lab with Chris. He'll show you around. And you need to, please, you understand that you are engineering students. You have access to all the resources of the school, and we are very well resourced indeed. One last thing. One last thing I'd like to say. Before you go to the lab, please listen to me. You need to be properly attired. So you need to have a shoe that's closed shoe, and shorts and short skirts are not allowed. Now listen. This is very serious. This is very serious. If you are caught in the lab with not following these rules, there'll be a disciplinary action. Yeah, so you'll go to the disciplinary committee, and I don't want this to happen. This is a game to prepare you as engineers, because when you become engineers, guys, please listen to me. When you become engineers, you will be the ones who is ensuring that these rules are being followed all the time. You had a question just now. You raised your hand. Just. Okay. You just repeat the question. Yeah.
Are the resources available to us at any time, or do we have to book the room in advance?
Very good question. So are the resources available anytime? So for example, you wake up 3 a.m., you cannot sleep. You need to use the lab. Is it available anytime? No. Now, during the working hours, which is like 9 to 5, the resources are available. You need to check with the lab technician if we have a class. So for example, if we have a class who is using the CNC machine or the rapid prototyping machine, you cannot just simply go and use it. So you need to just inform us. Now, closer to the, although I don't want to encourage you to do that, but the engineering students love this. Closer to the engineering fair or the test date for you, they will sleep in the labs for the last like 3 nights and manage to finish the project. For this to happen, you need to make arrangement. And the arrangement is, you come to Chris, Mike, or myself, there's a form to fill, because we need to ensure that there is a staff member with you. And no, he won't sleep with you. No, these people are very selective. Our staff are very selective. Okay, so to be with you when the lab is open to ensure your safety. There are certain things that you could borrow. I think if you need some ironing, solder, whatever, this we can lend it to you for the entire semester. So as the project unfolds, I would like you to keep on asking either myself, Chris, or Mike. Now, the key thing is, please start the discussion like today, because it won't take you anywhere if you come for the next class and say, yeah, I have this iPad and teach me how to do the robot, because this is not what we want to do. This is a high school level where we give you a kit, you put it together. You guys are now being prepared to be engineers, to create the future, to unlock the resources. So that's very important. And you recall the 3 things that I wanted you to remember, right? Yeah. Which are? Yeah, they're written there, you know. So dream big, be different, and have fun. So I really would like you rather to think of how to copy the other group, be different from the other group, and in the process have fun. Yeah. So we will by next week or so, we will actually give you the basic tools, which is the Arduino board, and we will start deploy a bit of training and things like that, so that you guys are up to date. Yes, a question here.
If it's during the process of making the robot, if the Arduino board is malfunction or is broken, spoiled, how? Yeah. Okay.
Very good question. So during the question is, during the work, the Arduino board malfunctions, broken, I throw it in the water or whatever. Yeah. Now, if this is an accidental thing, we will replace it. If this is really because of misuse of your group, you'll need to take responsibility. So we will tell you where to buy it, We'll tell you how much does it cost, and then because all these boards, we would like you to give them back to us because the next group will be building something else. Yeah. So, however, let's start on a positive note. You know, we have been always thinking. You know, let's think positively. Let's think positively. And if the Arduino board will malfunction and you have learned a huge technical lesson, I will replace it from my own personal, money. I don't really mind. But I don't want you to start with, oh, can I do this? Can I do that? You just take a bit of risk, but let it be calculated risk. So, for example, if you want to make a robot that moves on water, and you want to put the Arduino board there, make sure that it's sealed. Make sure that even if your boat takes water, the electronics will be there. So that's the part where I want you to predict sort of the future and be ready for it. But again, it starts here, right? So please think positively. But it's a very good question. Thank you very much. Any other question? Okay, then you could, yeah. So right. You can just go with Mike and Chris to have a quick lab tour.